In the summer of 1964, inside a concrete research facility in Marseille, a team of scientists was being torn apart from the inside by an invisible force. They were the first victims of what would be codenamed the Le Son de la Mort, or Sound of Death, an accidental discovery that unlocked the terrifying blueprint for a weapon that could kill without a trace. For weeks, the researchers at the National Center for Scientific Research endured a daily agony. It began as a low-grade nausea, a persistent hum not in their ears but in their bones. Soon it escalated. Vision blurred. Thought became difficult. A deep, inexplicable feeling of dread settled over the entire building. They described it as a pressure, a physical presence pushing in on them from all sides. The facility was swept for every conceivable threat. Teams searched for gas leaks, for undiscovered toxins, or for a breach in radiation shielding. Every test came back negative. The building was declared clean, yet the sickness remained, a silent, pervasive plague for which there was no diagnosis. The breakthrough came not from a complex diagnostic tool, but from simple observation. A scientist, pushed to the edge of his endurance, noticed a pattern. The torment was worse in certain rooms, at certain times. The source was finally traced not to a weapon or a poison, but to a piece of faulty infrastructure. An industrial ventilation fan, its motor improperly installed, was humming at an impossibly low, inaudible frequency. The sound it produced was a deep subsonic pulse measured at just 7 hertz. The researchers couldn't hear it, but their bodies could feel it. The building's concrete structure had become a massive resonator, amplifying the vibration and turning the entire laboratory into an unintentional torture chamber. For any normal engineering team, the solution would have been simple: fix the fan. But the lab's director, Vladimir Gavreau, was not a normal engineer. He was a pioneer in robotics and automation, a man whose mind was wired to see systems and their potential applications. Standing in the epicenter of this invisible agony, Gavreau did not see a problem to be solved. He saw a principle to be exploited. He understood instantly that if an accidental low-power vibration could incapacitate his entire staff, a purpose-built device could be a weapon of unimaginable power. The mission of the lab changed overnight. The goal was no longer to eliminate the sound, but to replicate it, amplify it, and aim it. The first experiments were crude, almost archaic. Gavreau's team began by building giant organ pipes far larger than any found in a cathedral. They were designed to replicate the subsonic frequencies, constructing massive whistles powered by compressed air, like scaled-up versions of a child's toy. The initial results were immediate and horrifying. Even at low power, these devices reproduced the debilitating effects of the original fan motor with terrifying precision. The air itself seemed to grow thick and heavy. Researchers reported intense pain, disorientation, and a primal fear. Then the designs evolved. The team built a device composed of multiple pipes mounted on a truck chassis. It looked like a bizarre rocket launcher, but it fired nothing visible. It was a true sonic cannon. The power was scaled up dramatically. Tests conducted in the Marseille facility began to cause physical damage to the structure itself. Cracks appeared in the concrete walls. Internal plaster shattered and fell from the ceilings. The building that had accidentally tortured them was now being intentionally shaken apart by its own amplified ghost. The team then developed a more focused device, a compressed air cannon designed to be a true weapon. Its power was measured in kilowatts, its effect instantaneous. The sound it generated was inaudible, a silent wave of pure kinetic energy. They documented every terrible milestone. Gavreau's team built a police whistle 1.5 meters long, powered by nitrogen. When they tested it, the sound wave was so powerful it physically ruptured the internal organs of the test dummies they used. They were forced to conduct subsequent tests in the open countryside of Provence, far from any inhabited areas. The ground would shake. Animals in the vicinity would reportedly flee in terror. This wasn't just a sound. It was a physical force, a blunt instrument wielded at the speed of sound, completely invisible and inescapable within its effective range. The project was no longer an experiment. It was the birth of a new category of warfare. The danger to the researchers themselves was extreme. In one infamous incident, Gavreau and his team were testing a new, more compact sonic device inside the lab. A technician, standing several feet away from the emitter, was accidentally exposed to the full force of the beam for mere seconds. He did not scream, because the frequency was inaudible. Instead, he simply collapsed as his colleagues reported his body was convulsing violently. The device was shut down just in time. The man later recounted the experience with chilling clarity. He said it felt as if his internal organs were being massaged so hard that they were tearing loose from their moorings. He was convinced that a few more moments of exposure would have been fatal. This was the first human trial, and it was almost the last for its subject. The core mystery was finally solved. The sound of death was not a mystical force or a poison. It was a terrifyingly simple principle of physics, mechanical resonance. Every object, including the human body, has a natural frequency at which it vibrates. The 7 Hz frequency of the fan motor was dangerously close to the resonant frequency of the human torso and its internal organs. When the infrasound wave from Gavreau's weapons struck a person, it caused their own organs to vibrate sympathetically, but with catastrophic intensity. The lungs would spasm, making breathing impossible. The eyeballs would resonate, distorting vision into a useless blur. The heart itself could be subjected to violent, competing rhythms, leading to cardiac arrest. It was the perfect weapon because it didn't attack the body from the outside. It turned the body's own physical properties against itself, inducing death from within. This discovery was not made in a vacuum. It was the height of the Cold War, and the French military took immediate notice. The potential of a weapon that could kill silently, pass through conventional armor, and leave no chemical or radiological trace was immense. The project was classified, and its results became the subject of intense speculation and state-sponsored myth-making. While the core experiments in Gavreau's lab are documented, they became the seed for more sensational legends, tales of sonic cannons that could rupture a city's foundations or kill an entire army in an instant. The reality was likely more limited, the physics more complex, but the confirmed science was horrifying enough. Gavreau had proven that the principle was sound, even if the city-destroying superweapon remained in the realm of theory. Vladimir Gavreau's work did not end in the 1960s. It echoed into the future. His research laid the groundwork for the development of modern non-lethal sonic devices like the long-range acoustic device, or LRAD. Used today for crowd control and maritime security, it is a direct technological descendant. It uses focused, high-decibel sound to create an unbearable sensation of pain, forcing targets to retreat without necessarily causing permanent injury. Yet the darker side of Gavreau's legacy persists. Rumors of classified military research into lethal infrasound have never ceased. Nations around the world are suspected of continuing the work, seeking to perfect the silent killer that was born from a rattling fan in Marseille. The sound of death was not a historical anomaly. It was the opening chapter in a new invisible arms race, and its final terrifying chapter may not yet have been written.